Alright, let's get started. Get my screen share up and running. There it is. Cool. Alright. Just still getting everything kind of ironed out here. So, I'm going to go over just a quick kind of recap of what we covered yesterday, kind of give us a sense of being able to contextualize what we went over. Let's do a sanity check here. Okay. So yesterday we went through lists and went through those really thoroughly. Talked about all the important functions and methods. Went over each of those just a little bit. I actually kind of want to. Oh, I closed that page. Let me do a quick highlights from that. Okay, let's just do some highlights from this real quick. So I know we talked about a lot, and it can be hard to like pick out what things are maybe more worth remembering than others. You know, ultimately, all of these things are important, but there's some that really we use all the time. Append, len, sum. Let's do sorted, max. Oops, it's not gonna work if I do that. Sorted, max, min, count, enumerate. And then this says parallel lists, but this is for this. Whenever you're dealing with parallel lists, zip is the tool. These two you usually see applied in a for loop. There are other applications for them outside of being something that you iterate through in a for loop, but overwhelmingly you see them, for I, L, I'll say IDX, L in enumerate list. Or you'll see zip sort of used in a similar way. Zip list, whoops. We'll say list A and list B. Imagining, of course, that these do exist, right? So we'll say A and B. So you usually will see zip and enumerate used in a for loop like this to some extent. Like I said, that's not the only possible place to use them, but that is overwhelmingly where you'll see them and use them. Yeah. So count, and I think is index not even on here? Maybe I'm missing it. I don't see index there. Index is also a good one. And maybe I should also add pop. That's another good one. So, yeah, these are kind of the highlights. I'll just leave these here for notes. Append adds an element to the end. Pop removes an element at a given index that you specify. Len gives you the len length of something. Sum gives you the sum of a list of numbers. Sorted returns a sorted version of the list without causing a mutation in the list. So you could use the sort function, and it might be slightly more optimal in certain cases, but just as an easy tool to get you started that's not going to have side effects that are going to be hard to predict, you can use the sorted function to return a sorted list. You can capture that list or use it in place wherever you need it, and it won't alter the list you're sorting, which is kind of nice. So it's a little safer, a little more predictable usage, a little easier to maintain, better tool to get started with. I generally prefer it, even though I know how to use both. I generally will choose sorted. So I'm recommending it not just as a tool for beginners, but because honestly, if I have a choice, it's what I choose. Cool. Min and max go together. It gives you the minimum or the maximum, or I'm reading these backwards, but the minimum or the maximum element in a list of elements where all the elements are of the same type. Remember, we looked at this. If we have a list of strings, we can do min or max, and it'll sort of give us the alphabetical minimum or the alphabetical maximum, sort of, and it uses ASCII or Unicode UTF-8 ASCII values to determine what string should come before some other string. But if you try to mix and match strings and numbers, things get weird because they're kind of incomparable. At least Python thinks they are. Count is kind of like len, if you think about it, right? Len gives you the length of the total number of elements in a function, or excuse me, in a list. Len is a function, so len list like this. Count, weirdly, is a method. And this will give you the count of a specific element in the list, right? So if I have a list and I can count 44, I'll get 2 44s, there's 0 99s, etc., right? So I think of count and len, I'll just leave that there, I guess. I think of count and len as kind of having a similar job. Len is kind of like count everything. Count is kind of like just count this one thing. If you're wondering why one is a function and another is a method, welcome to the club. I wonder the same thing. The decision to make one a function and another a method is often used. These two are often used to contrast each other when people are talking about like how you should make a decision about whether something should be a function or a method. It's kind of an arbitrary decision, you know. These have a similar enough job, yet they are implemented in different ways, meaningfully different ways. So, you know, there's some debate about that, you know. It's just the way it is, I guess is what I'm trying to say. So, anyways, then we have index, which is useful for recovering the index given a certain element. I'll leave it to you to kind of explore around and play with these on your own. Certainly, you know, I'm not telling you that these are the only methods and functions that you should learn. You know, like I said, you want to have a handle on all the concepts eventually, but these are the ones that I find myself using pretty frequently. So good daily drivers. Maybe those are the ones to learn first. And remember, if it can kind of seem like a daunting task to like memorize behaviors of every weird function, but if you kind of treat, for me, the IPO thing, input, we'll do this, input, process, output. So when you're going about understanding a new function or a method, or like I said, even an operator, you know, they kind of have these three aspects. Process is a little bit of a loose, it's sort of the loosest term here. I usually just use it for kind of notes on something. I usually think of, you know, what else does it do? Some of these don't have what we would consider an output. Output in this case means literally a return value. So some of these return none, like append returns none. I guess the rest of these return something. But some of the list methods don't return anything, and they cause a mutation instead. Pop returns something and causes a mutation. So in the case of something causing a mutation, I would kind of think of that as part of its process. I would think of errors as part of the process. So I would say use process for like mutations and errors that you might want to remember about something. Inputs and outputs, just remember to keep track of the type of something, right? So if we did this for len, for example, right? IPO for len would be len takes a sum collection, i.e. a list or string or tuple, etc. Its process in this case, I don't really care how it does what it does or anything. I can't think of any errors off the top of my head. There probably are some, but I can't think of any at the moment that len will throw. And then the output is an integer representing the length of the input. So something like that. It doesn't have to be long. In fact, it's better if it's not. You know, these are just quick notes. This is not everything there is to know about the len function. Like I said, you know, we could write about all possible errors, but you know, when you record an error, it's something that you might have encountered before, or something that you might want to take note of, right? So not necessarily like every possible error. So you can use this schema, input, process, output, and just kind of treat the terms a little loosely and a little subjectively as just a place for notes, and go about understanding new functions and methods that way. Okay, cool. Excuse me. Excuse me. It's a little dry in here. We got a question, is index a method? Yes. Index is a method. Index, let's just look at this. Index count, append, and pop are the methods in here. Okay, cool. So that's one thing that we covered. It was obviously most of what we covered yesterday. The other thing we covered was while loops. And we're going to talk more about this, but as this relates to everything, you know, and I won't go through the whole overview thing this time, but we have, in the overview, we have types, abstractions, control flow, types, abstraction, control flow, I keep making that mistake, and iteration. So lists fall under types, and while loops fall under iteration. So like I said, there's two iteration style tools that we're going to emphasize the most. They're not the only iterator tools in Python. There are other things that perform iterative processes, but for loops and while loops are kind of going to be your mainstay, and we're going to touch on comprehensions towards the end of the course, but for loops and while loops are what we want you to think of for now as your sort of main tools for that. So before we get into this, and some of you may have read this in the material recently, that's fine. I'm sure that was covered in the homeworks that we have assigned, or if you've gone through Learn just in general. So I'll put it to you all. Who remembers, how should I put this? Under what circumstance do I need to use a while loop, and I can't use a for loop? What's the circumstance where a while loop is necessary and a for loop won't do the job? Cool, we got a couple answers in here. Yeah, so a while loop is necessary when we can't determine the number of iterations necessary to complete solving a problem before the first iteration starts. So I gave an example of this, and I'll give this same example again. Is prime versus next prime. So def, if we do is prime, we'll take in n, and we'll say if n is less than or equal to 1, return false for I in range 2 to n square root. I don't remember if I did half or square root last time, but I'm going to do square root this time. We want to include the square root, so we'll do square root plus 1, and we'll convert all that to an int. This is going to turn into a float because I'm using this single slash division, which I kind of have to do there. Okay. And then we'll say if in mod I equals 0, return false. If we make it all the way through that loop without returning false, or return true. So the reason this works, by the way, you might think, oh, well, I could see somebody reading this and thinking, oh, well, if you return false, why is it not just gonna keep looping and then eventually also return true? So who knows why? Who wants to tell me why that's not the case? So if I return false, what mechanism is at play that will prevent us from also returning true? Okay, somebody's saying it ends the function. It being return, presumably. Yes, I'll take it that you meant return ends the function. Yeah, so the way when the Python interpreter encounters a return, it stops executing any further code. So if you have let's see, a number like, well, let's say 64, because I know the square root of 64 is 8. So 64 is not a prime number. It has quite a lot of factors. So you know, 2 is a factor of 64. It's even. It's an even number, so it's divisible by 2. So if we, excuse me, if we check 64 over 2, which is the first thing that we check here, 64 over 2 equals 0, which it does, so that condition is true. We return false. So this stops code execution, including any further loops. So it acts as a de facto break to the loop that it's within, but not because it's trying to break the loop, because it's more that it's not necessarily trying to break the loop as much as it's just trying to stop the function. So it just totally stops any further code execution, including if it's in the middle of a loop, it does not continue the loop. So that's the reason. And I'm just saying it that way to emphasize that return is that stopping is absolute. Okay, cool. Oops. So now let's look at our next prime function. So def next prime, we'll take in n, and I'm just going to do while. So remember our while loop, the syntax of our while loop is we have our while keyword, and then we have a condition. And the condition is just like a condition for an if, right? In that it's any expression that renders true or false. So all it has to do is give us back true or false. And that's a valid condition. The difference between, I mean, this is a close to a definition for an if as well, right? We have the if or elif keyword, and then some condition, and then a colon, and then indented on the next line after that colon, indented one tab width indentation, we have the body to be executed if that condition is true. The difference with an if is that if the condition is true, it executes the code in the body of the if, and then it moves on. After that code is done, it just keeps going down the document. With a while, it comes back up and checks if the it comes back up and checks if that condition is still true. And if it's still true, then it executes again and then comes back up and checks if it's still true, right? So usually, not always, but usually we have something that's like stationary and something that's static, or often we'll have something like that, or excuse me, something that's something that changes value and something that's stationary, right? So we have one thing that changes value and one thing that doesn't. In this case, we're just going to have n change values, so I'm going to say while not is prime. Now remember, is prime is basically my condition here, right? Because a condition is anything that expresses true or false. Look at what I'm returning from is prime. I'm returning true or false. So is prime returns a Boolean value, so I can use it as a condition. And I want to invert that condition. So when n is not prime, I want the condition in the while to be true, so I can keep looping until it's true that n is prime, and then not. So if n is prime, this function returns true. not true is false, and that stops the while loop. So that's the reasoning there. So we'll say n plus 1, and then I'll say n plus equals 1. And that's all I'm doing. That's the whole body of this loop, is just to increment n. And then since we're checking n plus 1, the reason I'm checking n plus 1 is I don't actually want to check n itself, right? If I pass in 11, which is a prime number, I don't want it to check if 11 is prime, because I want it to give me the next prime number. So if the current number is prime, I just want to skip that one. So the next prime number after 11 is 13. So I'll start by checking n plus 1. So 11 plus 1 is 12. So if 12 is prime, which it's not, so that's false. Not false is true. Then n plus equals 1. Then we'll say, so n now equals 12. So 12 plus 1 is 13. 13 is prime, so that's true. Not true is false, which stops the loop. After we find a prime number, we can return n. Since we checked n plus 1, we have to return n plus 1. One more than n. So let's verify this. Next prime 11. Oops. That's 13. We'll just run it again just to verify it. Cool. We could test this on a number of numbers. We could say for I in range, let's just do 20. And we'll pass I. There we go. Those are primes. Okay. So the big downside with while loops is that they're prone to infinite loops. Yeah, so you have to make sure that you're operating them correctly. If you don't tell it to stop, basically, it won't. It'll just keep going. And that can be potentially useful. I mean, there are situations where, you know, you want it to loop arbitrarily long number of times, right? So it gives you that control, but it also gives you the responsibility of having to do it. Okay, so we talked about the syntax. We talked about infinite while loops. One sort of cheaty sort of thing you can do, is a little bit cheeky. A lot of times you can get away with this. It's a hack, really, but there's sort of some safety in it. You can write a for loop with an that iterates through a range with an arbitrarily high upper bound, right? So this is what, 1, 2, 3, 6. This is 10 million. So for blank in range, 10 million. This underscore here is a valid name. There's a convention around this. It doesn't do anything special. Like, it doesn't have any special syntactic or semantic meaning in Python. The interpreter doesn't treat it any different as if you said foo or poodle face or I or whatever. Calling something underscore like this, it looks a little weird, but it's what it is. It's a declaration of your intent not to use this thing. So sometimes you just want to write a loop that executes the code within it n number of times, and that's all you care about. Like, I don't need for I in range, or I don't need an element from a list. I just need to do something 7 times. So to make it clearer that you're writing that style of loop, you do for underscore in range 7 or something like that. So if you're looking at that and wondering what that means, it's just a convention. It's not a different semantic or syntactic thing. The interpreter doesn't see it as any different than any other name. So yeah, so this is kind of effectively a while loop, probably for most situations. Most of the problems that you're going to be solving for now and for a while yet will not be dealing with needing to iterate through something 10 million times. This loop is really going to take a while to complete. Let's just run it and just take a look. We're in the 100,000s. Yeah, we're at 1 million. Or 2 million. So you can see this is going to take a while. So this is an extremely, even in my computer, it's, this is a big number. Obviously, we could go much bigger, right? This is not going to take hours. We're about halfway through already, but this is more looping than most problems that you'll solve will need. So you can kind of cheat and use a for loop like this to get an arbitrarily high number of iterations. And the reason we bring this up is if you're trying to debug a while loop and you can't quite get the condition right, and you just need to kind of run it a certain amount of times, but you want to set some sort of safe upper boundary where it's going to stop, you can do something like this and at least have some guarantee that it'll stop eventually. So it finally stopped just about now. So cool. Conditional while loops. The way this is phrased makes it sound like it sort of implies that there are non-conditional while loops. Unless there's some terminology around this that I have never heard of before. I've never heard of a non-conditional while loop. A while loop takes a condition after it, like an if statement. So don't let that fool you. While loops, I would say, are conditional loops. A lot of languages have some kind of conditional loops. Usually it's called while. Sometimes a language will have an until loop, which is, it sort of checks the opposite condition. So loop until something is true. But it's similar to a while. Okay, breakout. Let's do a breakout. I'll just actually screenshot this. Oops, that is... There we go. And I'll put 5 minutes on. it's time, go ahead and post your solutions, whatever you got. So I just stubbed out my function here. All right, so I'll go through a solution for this. So one thing I want to highlight here, I think I've talked about this before, is sort of good workflow habits. So I haven't actually written any code here that I would consider as like problem logic, you know, or that that's actually meant to start like solving the problem. This is all just sort of generic stuff to get me started. So I have this fancy test down here where I'm running for I in range 50 and then printing off the result of factors list with I and printing I next to it in this F string. So this is my test. Your tests don't have to be complicated like this. You could just have, just really as long as you have like one call, and since we're returning something, let's just do 30 something. Since we're returning something, I'll print off the function so I can see whatever it returns. So that's all you need, just something like that. I'll do my test like this though. And you can play around with it, do whatever you want. Then I just write the function head, and I'm going to be returning a list, and so I'm going to make an empty list and return it. And this is sort of setting me up for an accumulator pattern. Just by the way this is stated, I can tell it's an accumulator pattern. But whether or not at the time that I write this for a given problem, whether or not I know I'm going to use an accumulator pattern, when I'm just setting it up, I just assume I'm going to use an accumulator pattern. So, you know, just go ahead and create your accumulator. This is what we'll be accumulating into, and you're probably going to return it, so just return that. You know, if this is not what you need to do, if some part of this is wrong, you can always delete it. You know, that's the nice thing about it. But this is a good, just generic starting point. Okay, so now the cool thing about this is I can't, you know, like anytime if I make a move, if I write some code and I'm not sure what it's going to do, I don't have to like rely on my guess or my intuition or my memory of what I think it's going to do. I can just test it out. This is invoking the function, and since I'm returning this, since the whole goal of this function is to build up LST, this LST variable to return it, every time I run my function, I can monitor whatever it's doing. So that's nice. If there's any, like I said, if there's anything that I'm not sure of at any point, I can run print inside the function to kind of debug as I go, and since this is invoking the function, I'll see the results of those prints as well. So, yeah. I think I will actually just, I'm being wishy-washy. Factors list of 24. Okay, cool. So we just get an empty list. Let's start. Okay, so write a function that computes and returns a list of all the divisors of some positive integer. Use a while loop to do this. Think about how you determine if a single number is a divisor of another. Okay, so what is your stopping condition? So interesting note on this. Usually when I write a while loop, and I demonstrated this really quickly, I wrote a loop like this. Remember, a condition is any expression that evaluates to true or false. Well, true evaluates to true, so I'm just going to do a while true. I usually start my while loops like this. This is an infinite loop. Just by default, I'm just writing an infinite loop. And this kind of reminds me, yeah, like I've got to be the one to stop this. And often what I'll do is I'll just check a condition if condition break, and I'll just do this in here. I find this is easier to just get me started. So let's see. So first of all we need divisors. Or potential divisors. So let's just start I equals. We'll start I as 1 since it's a divisor. I'm going to be putting it as a divisor in a division problem. I can't start it at 0 because I'll get a 0 division error. So I'll start it at 1, and I will need to increment it. So I always like to keep my incrementation. So in this case, I is essentially my controller for the while loop. I'm going to call it a controller. So this is what's controlling the while loop stopping, ultimately. This is what's going to be controlling it. So in this case, I always like to keep my controller incrementation as close to the while loop head as possible, preferably like the first line. Sometimes you can't do that. You got to put it last or close to last. I don't really like to think about that too much because things can get messy. Like you think about it, oh, it needs to go last, except for this thing, except it needs to go before the, so I just try to write my code in a way where it's just right up front, and that makes it easy to keep track of. Because it can get lost. You get a few 10, 20 lines into something, and it can get buried in there. Okay, so in this case, since 1 is the first number I want to check, I actually will start at 0, and we'll increment to 1 immediately, and then jump into the rest of the code. Okay, so while true, I plus equals 1 if div... if in mod I equals 0, then we'll say list.append I, and we can actually do this cool trick. We can do list.append I over, n over I. And we'll only do this. Let's do this as an int too. We'll do that as an int. So the reason I'm doing this is, you know what? I'm making this too complicated. I'm opening up a whole another can of worms and making this more complicated than it needs to be. Okay, so we'll just do this, and if I run it, nothing's going to happen because we've got an infinite loop, right? So this will calculate the list, but it just keeps going. It's going to keep checking more and more numbers, even though it's impossible to get any more divisors because I is far and away well past n at this point. So in this case, I can just say if I is, I'll say greater than or equal to n. I don't know why it would be greater than, but I don't know. I'm paranoid, so I'm just going to make sure I'm checking equal to and everything greater than n just in case. Even though I'm certain I don't need to check a number greater than 10, but it's just on the way to, or greater than n based on the way that I wrote my code, but it's kind of a good practice to do that. Okay, cool. So if I is greater than n, I'm just going to break. Oh, and so if you have, so we've looked at several statements that end in a colon. We've looked at functions, conditions, while loops, and for loops. So functions, if, elif, else, for, and while, right? So those are the 5 that we've looked at that end in a colon like this and then have code indented under them. if you only have one line in the body of that particular statement, you can just put it on the same line like this. So I've been doing that. If that looks confusing, that's why. So I could do this. Okay. Cool. And let's see what they have here. Yeah, this is pretty similar. So it looks like they're starting divisors or divisor at 1, which is what I'm calling I, and then they're incrementing it at the end. And then they're using a proper condition in here, which is, I don't know, it's what you should do, I guess. I find this so much easier, honestly. I find it so easy to write a while true, and then once I get into my problem logic, it becomes obvious what I need to do to stop the loop. So I'll just be like, oh, well, if I encounter that situation where I is greater than n, I'll just break. I just find this easier to think about, easier to read and write and manage, but it's just me. Obviously, we could do this as a for loop. This would work. Honestly, this is better as a for loop problem. We can just do for divisor in range 1 to number, and I could do that thing. This function is actually kind of a superset of the isPrime function. It gives us all the divisors of something, so if we only had 2 divisors, we could tell if that number is prime or not, right? Based on how many divisors it has. Okay. Open-ended problems. So this is just a fancy way of saying, talking about a problem that we don't know where it ends, right? We don't know the number of iterations necessary to complete it. That's what we mean here. Oh yeah, I mean, that's literally what I just said, right? An open-ended problem is one where we do not know how many iterations we will need in order to solve the problem. Yeah. So the next prime function is an open-ended problem. Another example that sort of looks different is, let's say I'm building a let's say I wanted to build a text-based adventure game in the terminal. You have all the tools to do that now. If you want to do that, all you need to do is write a story and implement a text-based game in your terminal. So you would want a while loop that would take in user input in the beginning of it, and then make calculations based on that user input, validate the input, and then once it determines if it's invalid, then tell the user that it wasn't valid input and ask for valid input. If it is valid, then continue on with the problem logic, make the necessary calculations, and progress the game. So that's an open-ended problem too, and we would use a while loop, a program's main loop. You've probably heard of this, encountered this concept of a program having a main loop. A while loop could be used for that. Most cases when you're writing modern software, you're using frameworks that will obfuscate that main loop away from you, so you're not, these days in Python generally, you're not the one writing the main loop. You're implementing a frame loop or a framework that implements that loop behind the scenes somewhere, and you're interfacing with an API to that framework. So a framework would be like a Flask or Pygame, or you could maybe think of Django is another. Yeah, anyways, there's a few like sort of program frameworks like that for Python. Cool. And that's what this is getting into. This is building a little menu, right? This is not an adventure game, a text-based adventure game. It's just like a restaurant menu, right? You can, well, let's just, rather than me just explaining what it does, let's just run it. It's always good to let the code just speak for itself. So, okay. We've got, looks like an accumulator, I'm guessing. Yeah, so this is going to accumulate the user selections, and then another order is true. So while another order, oh, we don't need this, I don't know why that's there. So while another order, let's change the name of this to make order. Okay, so while make order is true, which it is, this looks a little funky, right? Because we don't have like a comparison in the same way that we would in an if, right? We just have make order. So a conditions come in many shapes. You know, they can look different, but again, any expression that gives back true or false, make order is a variable that gives back true in this case. So while true, that's how that reads. We just make this menu variable and print it off. Print off the menu string just to give the user a choice of what to do. And we could just actually, we don't need that menu string, we'll just do that. So we just print off the menu, select an item from the list, and then we take user input and it says, please make a selection. So I'll come down to my terminal, select from the list bread, butter, potatoes, broccoli, heck of a menu here. I'll go for some broccoli. I like broccoli. And then it asks me, would I like to make another order? I'll say yes. I'll say more broccoli, yes. I think I'd like some bread. And then I'll say no. And then it says your order list was 441. You know, obviously it doesn't do anything very fancy, doesn't tell me what my actual order was, just gives me a list with the selections that I made. So here's our input. So this is basically exactly what I was saying, right? We prompt the user with a call to action, you know, select from the list. And then we ask for input. We validate that input. So we say if input in 1, 2, 3, 4 selections dot append the input, else print your selection was not understood, and then continue. So continue, this is something that kind of got dropped in the end of one of the classes, but continue just skips one iteration of a loop. That's all it does. So it just continues on to the next iteration. It just says just go to the next iteration. So this is the input validation step that I was talking about, right? And you don't need to, I don't want to overload you with like concepts and, you know, input validation or whatever. But this is a pretty common sense thing to do, right? We would print off, here's your selections, and please make a selection. You take in an input, and then make sure that input's okay. You have a thing to do if it's okay, and a thing to do if it's not okay, which is to ask the user again to tell them that their selection was not understood, and then ask them to make a new selection. After that, presuming we got valid input, we ask the user if they want to make another order. Yes or no. We test the input if it's equal to y for yes. If it is, we just continue on to the next one. Else, we set make order equal to false, and then come up here and while false, we stop the loop that way. A lot of while loops look like this, especially if they're controlled with a variable. But this, to me, still, it feels like there's kind of an extra step in a way. We can just say break, and we could just say true, right? Because that's what this is doing. This is saying make order equals false, and then it goes up and just immediately breaks the loop. So I could just say break right here. Why not? And then we'll just lock this in the on position. We'll just say while true, and we can get rid of that kind of extraneous variable that we're not using anymore. So again, that'd be my preference, but you know, you do you. This is probably more conventional. So quick note, for loops versus while loops. In general, always use for loops to avoid infinite loops, and they just are nice to use. They give you elements from a collection. They're kind of nice. Will always terminate at the end of the iterable that you're traversing through. Useful when you know how many iterations are needed, or if you can guess a high enough number to get around any code wars or learn tests. However, there are some problems that should be solved using a while loop. Open-ended problems, menus, and run states. These are just different kind of open-ended problems. Okay. Let's just take a quick look through here. Okay. I think I'll just skip these breakouts for today. We'll take a short break here in a minute. There's going to be a slight addendum to the schedule. You may notice that we've kind of changed the schedule as we've gone through. Every time we run through premium prep, the way we deliver the material ends up being a little differently, or ends up being a little different. So we need to adjust, and we just kind of have that adjustment kind of built in. So I'm going to be teaching. I think it says tomorrow. I believe it says Tovio will be teaching, but we haven't updated the GitHub repo. So I'll be teaching tomorrow. So if you're wondering, we're not getting through all the material yet. We will be getting through all the material. I'm just going to take that extra day, and Tovio and I are going to trade days. So yeah, let's take a 5-minute break. Let's reconvene at 10 after the hour. Okay. I'm just taking some notes on what to cover here. It's going to be a bit out of order, but I'm trying to just order these in a simple way. Okay, so we've talked about strings. Y'all have some familiarity with strings. I'm going to assume you know how to declare a string. So to declare a string, we just use single tick or double tick quotes. Quick note on this, like you'll usually see the use of single tick quotes. That's usually the more the Pythonic thing to do. I believe PEP 8 even specifies that you should use single tick quotes for strings. I always prefer to use double ticks. You know, convention around this stuff is mostly like, you know, the conventions are there to standardize something so that there's some standard of consistency. You can break the rules in your own code, just be consistent. So I choose to use double ticks because I find myself using apostrophes, which are the same keystroke as single tick quotes. And that doesn't interfere with the strings. I find myself using apostrophes more than, say, quotation marks as characters in a string. So that's the reason there. Okay. Excuse me. But you can choose whichever one you like. So these are for single line strings. You can also make multi-line strings. Multi-line string is just a string that you can spread out across multiple lines. This prior solution actually, or this prior example, has a multi-line string in it right here, right? So where it says select from this list. Notice the triple ticks here, and you might say, oh, well, I thought that was a multi-line comment, and it is. So a multi-line comment in Python is a multi-line string. They're the same exact thing. We literally use multi-line strings as multi-line comments in Python, which is kind of funny, but also kind of cool. You can use triple single tick quotes to delimit a multi-line comment, or you guessed it, you can use triple double tick quotes. You can do either way. Yeah, so that's declaring a string. And as I'm sure you know, strings are Python's way of just storing and handling textual information, or the text aspect of information. And it's Python's way of dealing with it as text, right? Like, obviously everything's text. Like, we're looking at this and this number is text, but to Python it's going to treat this as an integer. It's not going to treat it as the textual characters 235. It's going to treat it as the decimal value 235, right? If I wanted to use it as characters, if I wanted to treat this as the actual characters, I would have to cast it as, or make it into a string like this. Okay, so CSI is a little acronym I use to remember concatenation, slicing, and indexing. We can also multiply strings, which I'll get into that in a second. So CSI, concatenation is a fancy word for adding two like groups of things. So hello plus world. Or let's be extra pedantic or something. I don't know. Hello plus space plus world is going to be hello world. My string equals this. Print. There you go. So there's our hello world. So we can concatenate strings, and this can come in handy in terms of like moving things around and just kind of manipulating strings in general. Everything that you learned about indexing into a list. So remember we had, so that's the C part of CSI, and then slicing and indexing. Everything that you learned about slicing and indexing a list, you can do with a string as well. So if I want to print the H in this string, I can say my string sub 0. So strings use a zero-based index. Their characters are in order, meaning that they can be indexed. Obviously, they better stay in the order that we put them in, because if they don't, then it's kind of a meaningless, if this was in a random order, then it would not be useful as a string. The order obviously really matters. So that being said, we can use an index to retrieve certain numbers, right? Or certain characters. So we'll see what's at 4. Looks like that's that O. So that's 0, 1, 2, 3, 4 at that index. Then 5 is going to be that space. Print nothing out, and that's because it's a space, we can't see it. And then 6 is going to be the W in world, etc. Okay, we can also, let's just slice out the world, or let's slice out O world. So we'll start at 4 and go to 5, 6, 7, 8, 9, 10. We'll just go to the end. So O world, I could do like O whirl. I'll just go to 9 or something. O whir. So I can slice a string just like I would slice a list, and instead of like getting the elements in a list out, I get single characters. So I'm slicing at indices of single characters. So each single character has its own index. So that's what's happening here. So that's concatenation, slicing, and indexing. There's also this weird thing we can do where we can multiply a string by an integer. This, you might look at this and think, oh, that would be an error, but it's actually not. We can do this, and it'll just repeat that string that many times. So this says hello world, hello world, hello world. Notice there's no space or anything. There's no elegance to this. It just kind of sandwiches them together in a really kind of, just brute force-ish way. So sometimes that can come in handy. Honestly, not that much, but so you can repeat strings that way. Tests for membership. We could say I'll just print this out. We could say hello in yeah, I'll just do my string again. In my string. So that's going to be true. We could say foo, and that's going to be false, right? So this will check any substring. So I could say ELL, and that's in that string. So I could check a single letter. Z, there's no Z's in there. So tests for membership is just the ability to test for any single character or substring in a list, or in a string. Excuse me. Case transforms. So strings are an immutable type. None of their methods cause any mutation to them. There is no mutable operation that we can perform to a string. All we can do is perform transforms. This is considered a transform. This is a transform. A transform is just like a different version of something with something changed about it. But it's a different object, and I could save that object into the same variable again. But yeah, I'm not actually mutating. I'm never changing the string. I'm just getting a different version of the string, and potentially I could reassign it to the same variable name. And I'll give you an example of that actually. Let's do this. So we could say my string. Oops. My string equals hello, and then if I print my string, and then I could say my string equals plus equals world, and then just print it again. Right, so we're accumulating stuff into here, but this is not changing on the level of the data type. It's changing on the level of the variable. Plus equals, remember, is syntactic sugar, so this is going to get turned into, literally Python just rewrites this internally as this. So it equals, this is like saying my string equals my string plus world. So I'm concatenating, and this gives me a different object back. It never performs a change to that string. So yeah. So I wanted to clear that out before we get into case transforms, because some of these can look like they would change the string, but none of the methods for strings will change it. So our case transforms, there are several more than this, but we're just going to cover lower, upper, and capitalize. And of the three, really the only one you should know is lower. Like, that's the one you use all the time. I'll show you why. Yeah, so I'll just reuse my string, print my string, hello world. So if I call my string dot upper, what this is going to do is it's going to take this string and it's going to return this with all uppercase characters. So it's going to uppercase everything. H-E-L-L-O. So if I run this code, what's going to happen? What string is going to be printed out when I print my string? Be specific with the casing, because that's the point here. Oh, and go ahead and put it in Slack is what I'm saying. Sorry, I didn't say that actually. Let's see. Just your regular string, not uppercase. Okay. Any dissenting opinions, or anybody agree, or maybe put a thumbs up or a thumbs down, or yeah, okay. We got another answer here. Hello world. So we got one in each camp here. We got another for lowercase. I really do want to get people's sense of this, you know, and it's okay to just give me your intuition, you know, if you're not certain, you know, just which one jumps out at you. What is this code? What does it look like it's gonna do? even if you just hazard a guess. Okay, let's kind of wrap this up a little bit. Whatever is in your myString variable. Okay, so who thinks, go ahead and put a thumbs up in the chat if it seems, if your intuition tells you that it's going to be uppercase. We got at least 2 people who thinks it's going to be uppercase. Anybody else? I do want to see where people are at on this. Okay. 3 people for uppercase. Okay. All right, so so this is gonna, let's just look at it. So this is gonna give me lowercase hello world. So the reason I wanted to kind of get a survey, a temperature check on this in particular, is that this has to do with mutability versus immutability. So the only way that the value of my string is going to change is if we, if we explicitly set it equal to my string equals something else. This is the only way that this variable can change. So apologies, this was a little bit of a trick question. I did kind of stack the deck, but I did this because if you look at code like this and your intuition tells you it's going to be hello world, we just, everything we've been doing with lists, that totally makes sense. But in order to save you a lot of pain, you know, take this moment now to realize, you know, that this is not, none of the methods or functions that will take a list will cause a change in its value. So, you know, how is it useful then? What the heck is this doing if it's not causing a change in this value? It's returning something, just like a function would. So it's returning an uppercase version of it. So I'll say res equals myString. I hope that didn't feel too much like a dirty trick. I'm not trying to like put anybody on the spot or like, you know, anything like that. But yeah, mutability is one of those things, like if you don't have a clear handle on it and you're trying to work with something, it can really feel like you're fighting something in a way that's just confusing and frustrating. So I just want to make sure that that's clear. Okay, so in this case, and I just commented this out just so we have one output. In this case, so what I'm doing is myString.upper, setting this equal to res for result. I'm just capturing that uppercase string in result and printing off result. I could just print off my string like that. So this is returning a value in the same way that any function returns a value. So even if I'm capturing it or printing it off, let's print off the value of my string just to make sure that that didn't change anything. It doesn't change anything, right? So this, just to be very clear, upper isn't going to change anything. No string method will. Okay. We can also do, let's do, I'll just do this. myString dot capitalize This capitalizes the first character if it can be capitalized. It does not capitalize something after a period. So if I had my string equals hello period world, it's not going to capitalize the world. It's not going to like make proper sentences. It's literally only going to capitalize the first character if the first character can be capitalized. Let's say I have a question mark or something in the first character. It's not going to go find the first character that it can capitalize. It's going to try to capitalize the first character, and if it can't, it's not going to do anything. So obviously there's no, well, if there is such thing as a capital question mark, I don't know about it. It's certainly not in ASCII. So it can't capitalize a question mark, so it just doesn't do anything. So capitalize only capitalizes the first character if the first character can be capitalized. And this would go for a space too, right? A space can't be capitalized. And I wanted to mention this kind of as an edge case because this could be easy to miss, right? This doesn't really look too different than just not having a space in front of it in my terminal, but you'll develop an eye for leading and trailing spaces because sometimes those can throw things off, and it's worth being precise about and knowing which things have leading and trailing spaces. Okay. So that's capitalized. The next one is my string equals so I just have this mixed case string. Print my string dot lower. Now you'll tend to see dot lower used as a sort of as a way of just ignoring case. A lot of times, like if you're counting, imagine you go through and you break up your string into a list of words. You break the string on spaces into a list of words, and you iterate through that list, and you've got some words. You want to see how frequently given words occur. Let's say, you know, like if you're just breaking this up from some corpus, some book or paragraph, you've probably got words that are the same word, but you've got like different cased versions of those. Some of them are going to be uppercase, maybe some of them are going to be all uppercase, some of them are going to be capitalized, probably most of them are going to be lowercase, right? Unless they're like a name or something. But you probably don't care about the different casings. You probably don't want to distinguish between those. Like the word potato with a capital P and potato with a lowercase p to you and I is the same word. It means potato, right? Either way. But to Python, it's like, no, those are two totally different things. Potato with a capital P and potato with a lowercase p are not equal to each other, right? So it's going to count those as different occurrences. So all that to say, there are a lot of times when you're working with strings, you just want to ignore case. So often what you'll do is just lowercase everything and deal with an all lowercase string just as a way of standardizing it, so you don't have to deal with what's uppercase and what's lowercase. You could use dot upper for the same purpose, but overwhelmingly everybody just uses dot lower. That's just how it's done. Cool. Count works exactly like it does for lists. It's a method. Again, it doesn't cause a mutation in the string. You might think, oh well, string methods were mutable. Most of the string methods we looked at were mutable. Count does not create a mutation in the string. Count does not create a mutation in a list or a string. So it exists for strings as well. So if I wanted to do This is actually a good example. Let's do this. Hello world. Say I wanted to count the number of L's. So if I wanted to print my string dot count L, right? It says I have 2 L's, and we're printing the lowercase version. That's kind of confusing. So it says we have 2 L's. If we look at this, HELLOWORLD. So again, this is not counting the uppercase L. How many uppercase L's do we have? We only have 1. Right, so we probably want to know about all of the L's in the string. So we'll say myString.lower. MyString.lower evaluates to an all lowercase version of the string. And then since this evaluates to a string, we can call string methods on it. So I'll chain these methods together, and I'll do myString.lower.count L, and this will tell me that there's 3 L's. So this is actually a perfect example of what I was talking about with why we use lower to standardize case, just to kind of ignore it, right? Like I said, you could use upper, but we always use lower. Why? Nobody knows. Replace. Replace is a good one. Replace sure sounds like it's going to cause a change to the list. So again, I'll test your intuition. And even though I'm asking it in a leading way, you know, take this time to like train your intuition and to see if your intuition would tell you something different. So my string equals, we'll do hello world again. Oops. My string dot replace L with question marks. So this will replace all the L's with question marks. Again, so what does your intuition tell you about what my string is going to return? Or what the value of my string is going to be when I print it off. And I know I'm being, it's obvious the way that I'm phrasing this what it is, but you know, I'm not asking for the right answer. I'm asking you to notice what your intuition tells you. So if you look at this and you're like, oh well, you know, if I call my string dot replace L with question marks and then I print my string, it'll print all the my string with question marks instead of L, right? So again, this didn't change the string. This did not change the string. This returns a string, res. I'll capture that return value in res, and I'll print off res, and it returns a string with all the L's replaced by question marks. So that's all it does. Again, I don't mean to put anybody on the spot or anything, you know. It's fine, but just it's worth it's worth you know, focusing on that idea of mutability versus immutability, because it's kind of a weird one. Cool. And we could, of course, we could replace this with any substring we wanted. So I could do like hey. So I could replace it with these hey tags or whatever. These are like HTML tags or something. I don't know. I suppose it's also worth mentioning I can replace a substring, so it doesn't have to be anything in particular. So let's say LO space W, and we'll replace that with hey. So this will say HEL, hey, world, right? World. So yeah, so that's replace. Casting, this is just a quick note here. We can basically cast anything to a string. So it's kind of the, universally castable type. It's kind of like what like a O negative blood type or whatever, universal donor. So stir of true. True. It turns out it's the string true. Big shocker, I know. False. I mean, can you guess? 57. So the reason, by the way, the reason I'm surrounding this in square brackets is so that we can see the quote marks around it. So I'm just putting it in a list just so it'll show us the quote marks. There's no other reason for that. 4.8, negative 0.8, whatever. So we can cast any other type to a string. Let's cast a list as a string. We'll say 8, 7, 2. I'm just going to case it, or I'm going to space it all wrong and lopsided. You can see when we cast it as a string, it just standardizes the spacing and formats the list like that. So we can cast, to my knowledge, I think you can cast anything to a string, at least amongst the built-in types. Okay. If you want to see, let's take a quick look at the built-in methods. Python 3. So the built-in methods, we could say dir string. So there are actually a lot of built-in methods. There's a whole lot built-in methods for strings. And again, we'll ignore the dunder methods for now. We're not going to go through all of these, I promise, don't worry. There's some of these that I've never even used myself. You do not need to know all of them, but there they are. There's a lot of them. And again, if there's, I would suggest doing this or just looking through this and, seeing if there's anything that that maybe that would help me find something in a string. Index. This is recognizable from lists. So strings do have an index method that works like it does with lists, except instead of, getting the index of a list element, you're getting the index of a character or a substring. Is alnum, is alpha. This is a good one. Is digit, is decimal. Is lower, is numeric, is printable. So all these is ones, I'm not going to go through all these, but all these ones that start with is, they're generally pretty self-explanatory. They all return true or false. So if I had a string that was just digit characters, and I said string.isDigit, let's to this IPython terminal again. So if I have a string of 243, and I do string 243.isDigit, or put the parentheses, true or false as to whether that's a digit or not. So if I put something in here that's not a digit, I just put a digit. Let's throw a random character in there. It's going to be false. So all these is ones are probably, they're worth at least playing around with. Is digit is definitely a useful one. That definitely comes in handy. Is digit and is alnum, or is alpha, is like if it's an alpha numeric character, if it's an alphabet character. So those two are really useful. The rest, I think I've used a couple of these in a couple different places, but those two I've used fairly frequently. So those are worth playing around with. But yeah, you can go through here and just kind of peruse and see if there's anything that catches your interest. zfill is one that I learned recently. It's pretty useful. I won't get into it, but it's got a pretty niche use. But anyways, so that's how we can see all the list methods. Again, if there's any one that catches your eye, you want to know more about it, you can say help. And let's say I want to do help on string dot is alpha. Oh, no parentheses. There you go. Return true if the string is an alphabetic string, false otherwise. A string is alphabetic if the characters in the string are alphabetic and there is at least one character in the string. Cool. List, split, and join. So we talked about converting things to strings. We talked about converting a list to a string, and you just get a string version of the list. By the way, when you get the string version of the list, the square brackets, the commas, the spaces, they're all just characters in the string. So if you iterated through that, you would literally get the square brackets and the commas and the spaces and the whole list as a string. Every character in it. It's kind of weird, but let's do... We'll create my string again, and if I cast my string as a list, so if I cast the string as a list, I get a list with every single character, notice including spaces. If there were punctuation characters in here, the punctuation characters would be their own elements in the list. So this is one of two ways to convert a string to a list. This is the less useful way, and the reason I'm showing it to you is it's the way that you might... I just want you to be familiar with this particular behavior. It's not that common that you'll really need to do this, but occasionally I've needed to actually literally cast a string as a list like this. There's another way, which is the split method, and it has a very different result. So let's call this split. Split string equals my string dot split on, well, we'll just do that. Oh, I gotta print something. Split string. Okay, so notice it gave me a list back, but look at the elements in the list. They're the words from the string, and actually this is more, bear with me just 1 second. Let me just, that'll be projects, no, oh, I'm in projects, Python, notes, I've got a thing in here. Okay, so I've got this text in here to play with. Oops. So this is just a little bit of text that I keep around just to play around with, just random text processing stuff. It's just a little poem. I don't have any special attachment to it. You know, it's just something to mess around with. Okay, so if I do, let's do this. So we've got text equals this paragraph, this little stanza from the poem. So let's say I want to create a list of the words in this poem so I can iterate through it and do something to that, right? I could do for word in text dot split, and it's quite often that this is the use case for split. I mean, there's other things to do with it. It gives you a list back so you can do all the things that you can do with a list to it. So let's see. For word in text.split. Let's just print word. There we go. And you can see this is going to print every word. So what split does is it's going to split the string into a list based on some separator character. There's no, I mean, you might be like, well, what separator character? How does it know to turn it into words? How does it know what a word is? Well, how do you know what a word is? A word is the thing that's in between the spaces, or that's separated by spaces. And spaces are just another character in the ASCII character set. So it looks for spaces. If I don't supply a character for it to split on, it will split on white spaces. This is a little weird because we think about spaces as being nothing. There are 3 different white space characters. One is space. The other is new line. So this is a new, this is a new line character. What I have selected right there, that's a new line character. It doesn't look like a character. It looks like you're just on a new line. But the reason my text editor in Python knows to process that as a different line is that there's a character that says go to the next line. And to ASCII and to Python and to the computer, the new line character is every much as a character as a U or a capital I or any other character. To us, it doesn't look like a character, but to ASCII, it is a character. So if I don't supply an argument for it to split on, it'll split on all white space characters. If I wanted to split on something else, let's say I wanted to split on O. This is a little weird. Oh, that's space O. I was like, what happened? This is a little weird because it's just going to be random. There's random O's throughout here, right? So notice each item in the list is, and actually I think I'll take it out of the for loop for now. We'll just print off the whole list. So each item in the list is the substring separated by O's, right? So notice, though, that there are no O's in this. So whatever character you split on is not represented in the substrings within the returned list that split gives you back. So you lose that character when you turn it into a string, or when you turn it into a list like this. Again, just to be clear, this is not causing a mutation in the string. We're just printing it off. Okay, so that's the other way, and probably the more useful way of converting a string to a list, or getting a list out of a string. So some of you might wonder, like, how do you split on multiple characters? If you don't, if you don't pass anything, it splits on, technically, it splits on multiple characters. There really isn't a way to split on multiple characters. It's kind of weird. You could chain it together with, actually, let me get that notes document back really quick here. I have a version of this string with punctuation in it. So let's say, so this has some punctuation. It's got a question mark and a period, right? Maybe I wanted to say, I don't want to iterate through the words. I want to iterate through the sentences. So I could say for sentence. So for sentence in text Oh, come on. So for sentence syntax, print sentence, right? So a sentence is questions are sentences as well as statements are sentences. But this is only going to be, oh, excuse me, actually I have to split on periods. This is only going to split on periods. So let's say I want to, I want to split on question marks and semicolons. I have to kind of chain replace in here. And I would replace question marks with the thing that I'm going to split on, which is period. And then if I want to split on semicolons as well, I'll have to do that separately. So I replace question marks with periods and semicolons with periods, and then split on period, right? And that'll split on all the punctuation there that we see. So there's another operation that sort of is the opposite of split, which is join. So if I have words list equals text dot split, and let's just prove it. Well, we've got words list. Yep. Written. Okay, so there's words list. We've got a list of words. So let's say I use my words list, I do whatever, or I accumulate a list of words. Somehow I produce a list of substrings. I can words string equals words list. Oops, I always do this. So I can join this back together. And join is kind of funny because technically it has all the elements of split, but in reverse, it is very much the inverse of split. So it's not common that you see syntax like this where we have a type literal that we call a method immediately after, but you usually call join on a literal string like this. On a string literal, whatever string you call it on is going to be the separator. Oops, and let's print off the words stir. There we go. Whatever string I put here that I call join on is going to be the separator. So if I do triple dashes dot join word list, it's going to join that word list together with dashes in between, right? So I think it's safe to say most often you just see a string with a single space in it, dot join words list. Maybe I shouldn't say most often, but quite often you see this. Okay. Let's say I had, for whatever reason, word list dot append. This is a list, so I can append to it 57, which is a number. This is going to give me an error when I try to call join. Sequence item number 30, so that's giving me the index, essentially. Expected stir instance found int. So when you join, you have to have a list of all strings, right? So often what you'll see here is a function called map. Map's a little bit weird, but it's a very useful one. Map stir, which is the stir function. Notice I'm not invoking it. I'm passing the uninvoked function, and what map is going to do is it's going to take every element from this second argument, which is going to be a list, and it's going to pass it to stir, and it's essentially going to give me a list back. It doesn't actually give you a list back. It gives you a map iterator object, which is an iterable object. But you can think about it as a list. And if you wanted to visualize it as a list, you'd have to cast it as a list. So, yeah, so it's going to give me, I'll just call it a list. It's going to give me a list of the results, whatever stir returns, when each element from word list is passed to it. So it's kind of like a little mini for loop in line. And this is actually one of the alternates to for loops. I'm talking about that there are other iterator systems in Python, and map is one of them. Cool. Great. We are out of time, but fortunately we're at the end of what I wanted to cover. If you're familiar with how enumerate works for lists, works the same for strings. You can enumerate a string. You can iterate through a string. You can say for character in a string and just iterate through a string directly. If you do that, you're going to get each character in the string, and there's a lot of times when that's really useful. And if you need the index for every character in the string, you can use enumerate to get the index of the characters in the string as well while you're iterating through it. So yeah, we already kind of covered that concept with lists, so if you understand it with lists, it's the same. All right, cool. Yeah, we'll just wrap up there. And let me just stop the recording, and we can open up for questions.